Hello, everyone. Welcome back to our channel, the series about data engineering and data science within Microsoft Fabric. Today, I have a special guest, Amir, who joins us to discuss data science experience and specifically samples, the ready-for-use samples that you can try and learn how to design your experiments within Microsoft Fabric. To kick things off, Amir, could you please share a bit about yourself with our listeners?
Sure. Thanks, Estera. It's my pleasure to join you. And hey, everyone. I'm Amir. I'm a product manager for the data science and machine learning on Microsoft Fabric. And I lead the work on AI and DS samples, as well as our famous Spark machine learning library, Synapse ML, and some of our LLM artifacts in Microsoft Fabric here at Microsoft.
Awesome. So let's dive right in. Fabric data science samples. Could you please share how many samples we have and what they are covering, and also which sample today we are going to discuss in details?
Sure. Let me just give you some introduction that I think samples play a key role. I personally think that you learn the best when you actually learn through a sample, because it walks through an end-to-end, step-by-step process, how to take steps to build samples. And in data science and machine learning, we're covering building and machine learning pipeline from end to end, from where you get the data to build a model, run different experiments, and then pick the best experiment. And at the end, hopefully you can also get some business intelligence from the machine learning model that you have trained. So we have different types of samples at Microsoft Fabric. We have some samples in Python, we have some samples in R language, and we have also some quick tutorials that actually help you to, if you want to do some learning of how to apply some sort of technologies, you can actually learn from those. Today, here, as you can see, this is Microsoft Fabric Data Science Artifact. You can go and use a sample. As I have told you, we have data end-to-end workflows for Python. We have R as well as quick tutorials. And in Python, we have almost about 8 samples. And today, we're going to focus on sales forecasting, which is about predicting the sales number for different product categories at a superstore.
Looks phenomenal. Amir, can you comment what are the prerequisites to try those samples?
So all you need is basically you need to kind of have a trial account at Microsoft Fabric, and then you can just, as I mentioned, if I go back, you can just go to Microsoft Fabric. You can just go to Synapse Data Science, and then you can just click on Use a Sample, and that's all. You have the access to all the samples we have. So all you just need to have a trial account with Microsoft Fabric. That's it. You don't need anything else.
Fantastic. So let's start with the demo and let's unpack this prediction sample.
Excited about it. Let's do it. The scenario of this notebook is to use historic sales data to predict the sales for different categories of products at a superstore. But why actually forecasting? Well, forecasting is an important and a very crucial asset in sales because it harnesses the historical data and predictive methods to provide insight about future trends. Well, by analyzing the past sales, identifying patterns, and even later learning the consumer behavior, businesses can actually leverage all those information to optimize inventory, production, and marketing strategies, and that would actually lead to overall performance improvement. So now let's actually go through this notebook and sample. Before we proceed, I need to remind that we always need to add a lakehouse, and which we have already done here, so you can see that the lakehouse has been already added. Okay, so we have already added our lakehouse, and now let's actually take a look at our data as our first step. Well, our data set contains around 10,000, or more exactly 9,995 instances of sales for different products, and these products are actually represented by 21 attributes or features, which include row ID, order date, ship mode, customer ID, country, city, state, postal code, region, category, subcategory, product name, discount, profit, and so on and so forth. Again, as you can see, this table kind of give a preview of how our data would look like. We have row ID, as I mentioned, all of these features or attributes for different products, and some of them are categorical, some of them are numerical. We have a set of parameters here that we can actually assign. It starts with if you want to use all of the data that you have, in this case 10,000 for your training or training a forecasting model, or you want to use a subset of that. And then you can also set up the data root, the folder name, the file name, and because we're going to train a forecasting model and we're going to log and track all of that, we also need to set up an experiment name, which in this case we have set up as AI sample dash superstore dash forecast. So let's just run this cell. As you can see, it's going to connect to the Fabric notebooks, and then let's see how long it takes. It should probably be done in a few seconds, pretty quickly. So as this is running, our actual data set is in a blob storage. So we can see that this is done in 12 seconds. Our data set is actually in a blob storage. We're going to download from blob storage, which is located here, and actually then upload it to our lakehouse. So let's actually run this here, and it would actually be uploaded to the lakehouse that's located here. Great, so this is also done. Now, it's always a good practice that when you're actually running a notebook or running a sample, to actually measure the time it takes to run the notebook. So I'm also going to do this to actually record the notebook running time. Now, as I mentioned, usually when you're training any machine learning model, including a forecasting model, it's very useful to actually log and keep track of all the experiments that you're running, because you're going to train different models, you're going to train even different models with different parameters. So traditionally you may have a pen and paper to take note of all of the stuff that you change, but it's actually helpful that now we have auto logging in Microsoft Fabric, and that would actually extend the mlflow auto logging capabilities. So it would automatically capture and log the values of the input parameters, output parameters, all of the evaluation metrics and scoring metrics of a machine learning model, including forecasting. So which is very useful. So for that, we actually need to import mlflow, and then we're going to use the experiment name. So all of the machine learning models that you're going to train, all of the runs going to be logged under this experiment name, which we already set up here, as you can remember, as AI sample dash superstore dash forecast. Okay, so we have done that. The data is in our lakehouse. So we actually want to read the data. So our data is actually an Excel file. So we're going to actually read this Excel file. Okay, great. So it's done. Let's just review what we did. So we had our data. Our data is in our lakehouse. It's an Excel file. So we read that data. Now, again, in any data science machine learning forecasting problem, the very first step is actually to perform exploratory data analysis, right? And for that, you actually first need to import libraries. Some of the common libraries for visualization, for some processing, which include for example, NumPy, Matplot, Seaborn, Pandas, and all of that, even some scale-learn metrics. So let's actually import all these libraries, and you could see that this actually doesn't take much. It should probably be very quick. So we can see that we are currently importing all these libraries, and again, as I said, in almost 13 seconds it's this done. Okay, so now we have imported all of the required libraries that you're going to probably use throughout this notebook, at least for the processing step. Let's actually look at the data. A good practice is actually you can probably look at a subset of your data to get a better understanding. And in this case, we're going to look at data using display function. So let's just run that and see that. So the display is actually, you see, it actually show me the different columns that I have, and it actually helps me to get some good understanding. I can browse all of these and then get some style, and then you can also see I can go on the chart view and I get a for ship mode and all of that. Is actually pretty useful. So I can, for instance, let's go to row ID and then look at here, and it's pretty very useful. So I can, doing that, I can get some good understanding of my data set. Now, in this notebook, if you look at it, we have different categories of products, right? But in this notebook, you can see that here we have different products like furniture, office supplies, technology, different things. I would probably, there are more about different stuff. So, but in this notebook and in this sample, the focus would be on the furniture category. The choice that we have made is just because to speed up the computation and for sake of like a easier presentation, we can realize that this can be easily extended to another category or even like multiple different categories and all of that. But again, for ease of like presentation and like to speed up the computation, we have selected the furniture category. So I'm gonna like actually select the furniture category here, done. And now let's again get into some sort of pre-processing the data. So in real world business scenarios, usually the forecasting of the sales is in three distinct categories. Either you want to forecast the sales for a specific category of customers, either you want to forecast the overall sales for a specific product category, or you want to forecast the sales for a specific product category and customer combination. So these are the usually like real world business cases. These are the three types of forecasting that we usually do. Okay, as again, if you take a look at here, we can see that we have so many different columns. If you remember, there were like 21 different columns. And now that we have decided that we're only gonna look at a specific product category, we kind of realize that some of these attributes or features may not necessarily be useful. So if we can, for example, because they are not useful, we can possibly drop some of them. For example, like row ID, order ID, ship date, and all of that, region, and all of that, they may not be very useful. Again, because the focus is on the forecast, the overall sales for the furniture category across the state and region, we probably can like drop columns such as state, region, country, city, postal code, and all of that. So here we have actually decided the columns that we don't think they are very informative and very useful for this specific use case. So we're gonna just drop them. Again, I need to clarify that we are looking at a very specific scenario, but again, based on your own use case and like what you have in mind, you may decide to keep some columns, or you may even decide to drop some columns. In this very specific case, we realize that we just want to look at the overall sales for a specific product category. So we realize that many of these columns are very redundant. So we're gonna actually drop them. We see we drop them pretty quickly. Great. Now, the other thing that we have realized is that our data set is actually structured on a daily basis, right? But we want to develop a forecasting model to forecast the sales on a monthly basis, right? So now we actually need to sample on the column order date, right? So that's the next step that we're gonna do. So what we're gonna do actually, we're gonna first group the furniture category by order date, okay? So first step, group the furniture category by order date. Then we're gonna calculate the sum of the sales column for each group in order to actually calculate the total sales for each unique order date. Again, I'm repeating myself, but I think this helps to better understand. First, we're grouping the furniture category by order date. Then we calculate the sum of the sales for each group. And we are doing this because we want to get the total sales for each unique order date. Now, because our order data is basically, again, the data is based on like the daily basis, but we want to kind of predict sales on a monthly basis, we need to resample the sales column using the MS, which refers to month category, to kind of aggregate the data by month. And then you can actually calculate the mean sales value. And this cell is actually basically doing that. So again, you group by order date on the sales, then you sum of the sales for each group, then you kind of get the total sales for each unique, and then you actually do the resampling by month. So we do that, and now let's actually kind of have a look at what's the impact of this order date on sales. All these like kind of visualization and pre-processing actually help us to gain a better understanding how our data looks like. Does it actually make sense? Are we seeing something like that is questionable and all of that? So we can see that, okay, we can see that depending on order date and sales, sometimes, we have some peaks in the sales around July. Could be, for example, an event, all of that. You see that, like, for example, like, again, like late July of like 2021, we see some sales has dropped. And again, we saw, this actually helps us to see like, okay, can we actually map these sudden increase or sudden drop in the sales to some incidents or events and all of that. So this is actually very useful to gain up some insights. Now we actually want to get into some sort of a statistical analysis, right? But before that, we actually need to import the stats model as a Python module that actually help us to perform some statistical analysis. So let me actually run that, and pretty quickly we done that. Okay. So, in every forecasting model, you actually need to do a statistical analysis, right? And any time series actually tracks 4 data elements at set intervals in order to basically determine the variation of these 4 elements. And so these 4 elements in any forecasting model or time series model include like the level, the trend, the seasonality, and the noise. So as you can see here, the level actually refers to the fundamental component that actually represent the average value for a specific time period. The trend refers to the whether the time series is actually is decreasing, or is it increasing, or is it like constant over time. Seasonality is actually referring to the periodic signal in the time series, and actually kind of looks for the cyclic occurrences, as the name suggests, like a seasonality. Are we seeing some sort of periodic cyclic occurrences? And the noise actually is the random fluctuations and variability. And in any time series or forecasting model, we kind of try to look at all these. So now let's actually decompose our time series into these 4 elements and take a look at them and see what insight we possibly can get. So we have written the code that actually decomposes a time series, and great. So you can see that now the 4 elements that we mentioned, the residual or noise, the trend, or the seasonality that we mentioned here, we are actually seeing all of that. And again, this would actually kind of give us some sort of insight that, okay, do we see some sort of a seasonality or like a cyclic periodicity here, or like trend, or like do we see some sort of a residual or noise and all of that. Great. So we also get into some sort of a statistical analysis. Again, understanding all of these allows us to actually capture underlying patterns and develop models that actually make more accurate predictions. So this is a very useful step. Now in next step, we actually want to train a model and track, because so what we have done, we got our data, we kind of pre-processed the data. The data was on a daily basis. We wanted to kind of do it on a average monthly. So all of that. So we have our data in place. And now we want to actually apply a forecasting model. Now, the forecasting model that we have in mind is actually the seasonal autoregressive integrated moving average, also known as sarimax. Sarimax is actually a well-known time series forecasting model that extends another well-known machine learning forecasting model, which is called Sarima, to actually include exogenous variables. So it actually kind of combines the autoregressive or AR and moving average MA components and seasoning and all of that together. Again, if you remember, we define an experiment name. So we also will use the mlflow and Fabric auto logging to track the experiments and all of that. For any forecasting model, you actually need to some sort of the metrics that you want to evaluate. So let's import those record matrix from scikit-learn. Some information or background about sarimax. Sarimax actually combining the ARIMA model with some seasonal parameters. So an ARIMA has 3 parameters like PDQ, but then Sarimax actually include the seasonality. So then it becomes PDQS. So then the arguments to Sarimax I'll call PDQ, and then the seasonal one PDQS. Again, we can briefly talk about what does it actually mean. The P is the order of the autoregressive component, and it kind of indicates how many of the past observations are considered. Q is actually the degree of differencing, which kind of refers to it's actually used to make the time series stationary, and Q is the order of the moving average, and it actually shows how many past white noise error terms are considered. Now PDQS, or the capital one, is all of those what with seasonal part. So you add the seasonality effect to all of that. Except the S, which basically is the number of time steps per seasonal cycle. So for example, 12 for monthly data with a yearly seasonality. So now we do need to do some sort of hyperparameter tuning. So for PDQ, we kind of decide the range between 0 and 2, and then we're gonna do use the iter tools to kind of create different combinations. So actually let's run that. Okay, great, that's run. We provide some explanations about like how different values and all of that means, which you can walk through that, or like you can read it on your own time to better understand. So now actually we want to tune the hyperparameters to determine the best model. So actually let's run this model. It would actually probably take some time to actually find the best set of parameters. You can see that. But ideally what we actually want to do, we want to find a set of parameters that actually offers the lowest AIC for us. Great. So let's see if it's done running, or is it still running? Okay, great, it's done. So we can see that the choice is the order of 011 and the seasonal order of 0112. If you look at here, we can determine that's the order that actually gives us the lowest AIC, which is equal to 279.58, and that's the best parameter. So now we have found that the best parameters from the sarimax algorithm. So now we actually want to train a model. So we actually provide those parameters, which is again 011 and 01112, as you can see here, order and seasonal order. And then we actually now want to actually train an actual model. So let's actually train our model pretty quick. So again, very quickly. So we have trained a model, and then we can actually look at the different metrics that we have. So we have trained our model. Now actually let's move to the next step, which is actually visualize a time series forecast for the furniture category sales data. And we're going to show both the observed data and one step ahead forecast. So let's take a look at this one. So you can see that this is actually the actual sales, which shows like up until like 2023. And this is actually the one step sales. Great. So we also see that. Great. Now we want to actually validate the forecast results, and we want to forecast on scene data. As I mentioned, we're going to always use mlflow for auto logging and tracking the experiments. So we're going to log the model and parameters. So you can see here that the model name is actually like experiment name that we have chosen. Here all the at the very top, if you remember here, yeah, this is the experiment that we have set up. AI sample dash superstore dash forecast. Our model name is very similar to that one beside the sarimax. So let's actually do that, and then this actually allows us to actually log all of the models. So all of the models that we have trained, you know, the parameters and all of that, we actually will be logged into mlflow. So that would actually be very helpful for us, because you can always go to your experiment. You can go to your workspace, you can select the experiment name, and you can actually see the results of your model training. You can like track all of that. So you can see here, for instance, it shows that if you go to sarimax and all of that, you can see the run parameters, the seasonal order, you know, all of that, which is very helpful. Now we have already saved the model. You know, if we save the model, now let's load the save model. And now that we have saved the model, let's actually make some predictions using our saved model. So here we're going to make some predictions. You can see that. So for example, and it's actually now showing us the MAPE score, which is a very common metric to evaluate the performance of a forecasting model. And now, sort of that we have actually sort of built a forecasting model, made the predictions, we have saved that, and now we actually want to save our prediction results to our lakehouse. Because again, as you know, in many machine learning and forecasting problems, once you build a model and you train the model and made predictions, it ends there, and that's partially the reason that many ML projects fail. Because they lack that business insights, right? You need, once you train a model, the value is that you actually can turn these insights from your model, the prediction from the model that you have trained, you actually can take it to business actions, right? And like look into some sort of insights that helps you take actions to improve the business, right? So, and that's where actually comes that the reason that we're actually save the prediction results to a lakehouse is that we can actually save the data in the lakehouse and actually take it to Power BI to actually create a Power BI report and like that, so we can see that. So now we actually have done that, and so now here we actually see the forecasting results. So you can see that the light blue one can show the sales, and the dark one is actually show the sort of the forecasted value. So we can see here, and our MAPE value, which is referring to mean absolute percentage error, is around like 16.5, and MAPE is actually a very common metric that defines the accuracy of a forecasting method. and it shows like how accurate the forecast is comparison to the actual values. The 10% usually, for example, like 16% could be like 16% more or less. It really depends on the use case and the business to determine whether like 10% or 12% or 15% is actually an accurate one or not. But we can see here that the dark blue and like the light blue, which is like the actual versus the forecasting, they're pretty close. So now we are able to actually kind of even forecast in future. And we can see that, for example, that, okay, let's say like towards the late 2023, we're going to have some sort of an increase in sales, and then we're going to see some drop in the sales, and then back in sort of 2024, it's going to like, again, pick up the sales. So overall, again, what we kind of tried to show in this sample and notebook was that to kind of showcase an end-to-end forecasting problem for sales of product category in the superstore sales. We took from very early step that we took the data, we create a lakehouse, we have our data uploaded in our lakehouse. We define an experiment name because in any ML model training, we want to log the parameters and all of that. We did some sort of a exploratory data analysis. We look at our data. We pre-process the data to fit the purpose that we have. In this case, we wanted to kind of look at the monthly sales. And the data was initially on a daily basis. So kind of did a resample on a monthly. And then, we look at how the sales doing, and then we look at the statistical analysis, the trend, the seasonality, and all of that. Then we decided to actually use a sarimax to train a model. So we use sarimax, we define the range for the parameters, and then we try to find the best set of the parameters that would result the lowest AIC number. And then we found the parameters, and then we train a model, and then you see, we look at the prediction results, save the predictions, and we took it to Power BI for actually business insights to help us what we can do. So if, for instance, we can see that if our sales are dropping, is there anything we can do to help that? Or if there would be a reduction in the sales, maybe we do not need necessarily that much in inventory. But those are all just my hypotheses, and these are all subject to like business experts and domain experts to look into that.
Amir, the demo was fantastic. I want to follow up on the idea, because here you presented forecasting, prediction, and I'm just wondering if that's something what you came up with, or maybe you are working with some customer partner on such advanced demos.
Yeah, that's a great question, Esther. Thank you for asking. I'd like to mention that we actually built this sample in very close collaboration with one of our partners, Sonata Software. And what is very important about this sample is that we try to make this sample as close as possible to a real-world use case scenario of forecasting the product sales. If you even go towards the end of the sample, as I just demoed, you could see that we also have a business intelligence, like you can actually predict the sales for the next 6 months. So we try to kind of follow what is actually done in real world use case for forecasting. And I think that is one of the things that would actually resonate with our users and our customers, to actually see that this is a very practical sample, and would help them to actually, maybe with some minor changes, adopt it to their own forecasting use cases.
That's super great. I love that we mentioned about it, because it shows a huge opportunity for our partners and customers. I'm coming from the field organization, so I work with Microsoft partners and customers, and many of them would love to share the examples, the work they are doing somehow. They are right now tackling blogs, YouTube, different portals, different solutions, different ways to advertise their work, but the best way is to plug in the sample with some maybe unique scenarios, or maybe some just examples of how they are using our tool to build data science solutions. So thank you for mentioning that.
Of course.
Okay, so that's all for today. If you enjoyed this episode, please remember to hit the like button and subscribe. Also, please leave the question, comment for me, for Amir. We want to help you, and also that can be a communication channel with us. You can also drop the idea, what would you like to see in the upcoming videos, maybe also in the upcoming samples. So until the next time, happy discovering data science samples with here predictions and forecasting. Thank you.